Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NEET, GATE, NT exam, PhD exam, SET exam, IIT-Jam, Tifr, Jest and other exams related to physical science. Okay. So this is the lecture number 3rd of electronics. Okay. In which in last lecture we have studied nodal analysis, right, and Kirchhoff's law. So today we are going to solve some more questions of nodal analysis, and then we'll study KVL. Okay, that is his law, right? Okay. So guys, before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so let me just check whether I'm audible or not, then I'll proceed further. Okay, thus I would request, yes, I'm audible, so I'm going to proceed further. Okay, so I'll start with the question of nodal analysis. Question number first. Okay, so this is the question of nodal analysis. Okay, so I'll make a diagram. By nodal analysis, we can easily solve complicated circuits, right? Okay, so this is 10 volt given, and this is 4 volt given, and this is 2 volt given. Okay, and this is 3 ohm, this is 2 ohm. Okay, and this is 1 ohm. Okay. Well, this is the question, guys, and we have to solve it. Okay, so and then we have to find the current, right? So we can easily solve it by nodal analysis. Okay, which I am going to do now. Okay, so some questions we have already solved in my previous lecture. Okay, well, so how we are going to solve it, guys? This is a little bit different from the previous questions. Okay, so there's a procedure of solving this, right? So voltage at this point, and this point should be equal, guys. Okay, so how are we going to make that voltage equal? Okay, so what we are going to do is, suppose the voltage at here is x. Okay, and here also be x, and here at this point also be x. Okay, so voltage will be same at these 3 points. Okay, now we'll take voltage here and here and here. Okay, so here you can here the voltage is going to be this voltage, right? This is going to be, here we can make a voltage, so that should be 10. 10 means here voltage should be x minus 10. Okay, x minus 10, because x minus 10 means x minus 10, that is going to be that's going to give 10 volt, right? And similarly here it is x and this is 4, so this should be x minus 4. This is negative terminal, right? So x minus x minus 4 is going to give 4 volt. Okay, similarly here this is going to be x minus 2. Okay, so this is the voltage, and we can take that 0 voltage. So here it is 0 voltage and it's 0 and this is 0. Okay, now we can easily use that we can use nodal analysis method, KCL, and solve it. So how it is going to be now? So it is going to be this one. For this point it is going to be, for this point, right, it is going to be x minus this point. Okay, x minus 4, this one, guys, just wait. Okay, not this one, like here we'll take, right, this one, x minus 4, because these are the voltage difference, right? In between there should be uh, resistance. So this is going to be x minus 4 at this point. Okay, x minus 4 minus 0 upon 2, right, plus this is going to be this one, x minus 2, x minus 2 minus 0 upon 2, right, and then plus this one, x minus 10, x minus 10 upon 3 ohm equal to 0, right? So very simple, guys. So what we have done is we have taken so because at these 3 points voltage should be equal, right? So we have taken x. Okay, and we can take 0 at we have taken 0 at these 3 points. Okay, at this point it's a 0, so these 2 points 0 will be also at these 2 points, right? So now this is 10 volt, right? So here the voltage is going to be x minus 10, because that difference is going to give 10. Similarly, this is x minus 4 because difference is 4, x minus 2 because difference is 2 volt, right? So this is the KCL equation by nodal analysis. Now we can solve it. Very simple calculation. So this is going to be x by 2 minus 2, right? This one plus x by 2 minus 1, right, minus 1 plus x by 3 minus 10 by 3 equal to 0. Okay, so now we'll solve it. So this equation is going to be, we solve it. So this is going to be x by 2 plus x by 3 plus x minus 4. Okay, this is 4, guys. Okay, this is 4. This is going to be minus 4 and minus 10 by 3 equal to 0, and we'll take LCM. LCM is going to be 6, and this is 3x plus 2x plus 6x minus 24 minus 20, that is going to be equal to 0, right? And from here it is going to be 11x minus 44 equal to 0, and value of x is going to be 44 upon 11, that is 4 volt. Okay, so value of x, this is 40, this is 4 volt, right? Now we can easily find the current here, current here, current here, right, very easily. So if we have to find current at this point, so this is going to be 10 minus 10 by 3, right, and in place of x we'll write 4. So this is going to be 4 minus 10 by 3, right, that is 6 by 3, that is going to be minus 2 ampere, right? So very simple question, guys. I hope you have understood it. Okay, so this is the one, guys. Okay, well, it's a simple calculation. Next question. Question number 2. Question number 2 is I'll I'll make a diagram first. So this is going to be like this. This is is the figure. First I'm drawing the figure, and this is the one. Okay, so this is 10 volt, guys. Okay, this is 10 volt, and this is 4 ohm, and this is 40 volt, and this is 8. And these are complicated circuit, and we are using nodal analysis method to solve this type of questions. Okay, so this is 8 ohm, and this is 4 ohm, this is 2 ohm, and this is 2 ohm. Okay, right? This is the circuit, guys. Okay, so these are the values, and now we have to solve it, right? So we can easily solve it by a nodal analysis method, right? So for that we'll use nodal analysis method. Okay, so here we have to take points, so we have to choose point. Okay, so here I'm going to choose. Okay, so at this point the voltage is x, guys. Okay, if this is the voltage x, means this is going to be x plus 10. If we get the difference, that is going to be 10 volt, guys. Okay, because it's a plus part, that is why it's going to be 10 plus x plus 10. Okay, and here uh, you can see this is the 40 volt, this is the positive part, right? So this is 40 volt, means here it's also 40 volt, and here also it is going to be, right? uh, now here if we choose it, so this is also x plus 10, x plus 10. Okay, x plus 10. Okay, and here this is 40, means this is 0, guys. Now at this point we are going to choose another voltage, that is y. At this point voltage is y. Okay, okay, so and at this point this is a positive part, right? So this is going to be x plus 30, because if we get the difference of this is going to be 20, right? X plus 30. Okay, so now very simple, we have chosen these points, and we have and this point, at this point the voltage is x. Okay, at this point voltage is y, and then we have got these values of voltage, right? Now we'll use a nodal analysis method, right? So this is going to be, for this point, this is right. For this point it is going to be this one, x minus 40 upon 4, right? At this point it is going to be x minus 40 upon 4, x minus 40 upon 4, right? X minus 40 upon 4, and then we'll take this point, right? So x minus 40 upon 4, and here we'll take it this one, right? This is going to be plus this one at this point, x plus 10, x plus 10, this one minus 0 upon 8, x plus 10. Okay, x plus 10, x plus 10 minus 0 upon 8, this is 8, and here it is going to be this one, at this point, x plus 30, x plus 30 minus y upon 2 equal to 0, right? And for y it is going to be y minus x plus 30 upon 2, this is for x. Okay, for x, because we have chosen two variables, right? Two voltages. Now for y it is going to be this one, y means y minus y minus x plus 30 upon 2, right? Y minus x plus 30 upon 2 plus y minus 40 upon 2 plus y minus 40 upon 2 equal to 0, right? And more point, guys. Okay, y minus 40 upon 2 ohm, and then plus, here you can check, there is this one I, right? Y minus 0 upon 4. Plus 0 upon 4. Y minus 0 upon 4 equal to 0. Now this is equation 1, and simple, right? So we'll get the we'll get the equation in xy, right? And then we'll solve it and we'll find the value of x and y, right? And then we can easily find the current. Okay, so guys, I hope you have understood it, right? So now I have explained how we are going to choose these points, and then how we are going to use nodal analysis, right? And after that, there's a simple calculation, right? You just need to solve this, and here if you solve it, you will get an equation in xy, and if you solve it, you will again get a in xy, right? And then you need to solve those equations, and you need to get the value of x and y, and then you can easily get current at any branch. Okay, well, so this question is done. Next question we are going to do. Next question is, next one more question. Okay, so I'm going to solve. So you need to understand, okay, how I'm choosing the points and voltage. Okay, and then I'm using the nodal analysis method. Okay, now question third is this one. I'll make a diagram first and then we'll solve it. Okay, this is the circuit. I would suggest you solve questions, okay, and use nodal analysis. Solve questions related to circuit, right, and use and try to solve those questions by using nodal analysis for practice. Okay, so this one. So this is 10 volt. This is 4 ohm. Okay, this is 40 volt, and this is 8 ohm. This is 4 ohm. This is 2 ohm. This is 2 ohm. This is 20 volt. Okay, this is 40 volt, 10 volt, and 4 ohm, right? This is the question, guys, and now we have to solve this. Okay, so how we are going to solve it, I'll show you. Okay, so we are going to choose a point. Okay, so at this point we are taking voltage as x. Okay, at this point voltage is x. Okay, so this is 40, right? So at this point the voltage is going to be x plus 40, right? Then the difference is going to be chosen voltage 0. Okay, so we can choose 0 at any point, right? So 0, so it means this is going to be 0, as in previous question I have shown, right? Previous to previous question, here we have chosen 0 at this point. Okay, well, so this is 0, this is 0, means at this point we can choose point, right? So this is going to be x minus 10, x minus no, my apology, it is going to be minus 10, okay, minus 10, because 0 minus minus 10 is going to be 10 difference. Okay, this minus 10 volt, this is minus 10 volt, this is this one, and this voltage is also x plus 40, right? And here we can choose voltage y. Okay, so here it is going to be, it is 20 volt. Okay, so these are the voltage. Now we can easily use this nodal analysis, that KCL by nodal analysis. So now that is very simple. So this is going to be x for x. Okay, for x, this is going to be x this one, x minus 0 upon 8, x minus 0 upon 8, right, plus x minus y upon 4, right, and plus this one, x plus 40 minus minus 10, this is 10, okay, 10 upon 4 plus this one, right, and this is the one, and this one, this in this branch, this is going to be, this branch is done, right, this branch, this is going to be x plus 40 minus x, no, this is not correct, this one, and next is okay, something missing, this one, yeah. X minus y, right, and this is x minus this one at this, right, so this is going to be x plus 40 x plus 40 minus y upon 2, this is equal to 0, right? We can solve it, we'll get a equation in xy, right? Now for y, it is going to be dy, right? Y minus x upon 4, y minus x upon 4 plus y minus x upon 4 plus y minus 20 upon 2, y minus 20 upon 2 plus next is, and this is y minus 20 upon 2 ohm is done, and y minus x is done. Now this one, y minus x minus 40 upon 2, right, y minus x plus 40, y minus x plus 40, y minus x plus 40, y minus x plus 40 upon 2 ohm, right, 2, that is equal to 0. So we can easily solve it, right, and we'll get the equation in xy, and we'll solve this equation, and we'll get value of x and y. So you can do it, right? It's a very simple calculation, you can do it, okay, and procedure I have explained, right? So this is the this is about the nodal points. Okay, now we are going to study that Kirchhoff's voltage law, okay, KVL. So this is Kirchhoff's voltage law, okay, Okay, so Kirchhoff is a German scientist, guys. Okay, and in English we say, in English pronunciation of this is Kirchhoff voltage law. Okay, so you can say Kirchhoff's voltage law or Kirchhoff's voltage law. Okay, it's a German. He's a German scientist. Okay, Kirchhoff. Okay, so well, so I'll explain this law. Okay, this week we say KVL, Kirchhoff's voltage law. Okay, and this is also called loop analysis. Okay, that KCL is called that is nodal analysis, and this is loop analysis. Okay, loop analysis. So we'll choose the loop and then we'll analyze that. Okay, so loop analysis, loop analysis, loop analysis. Okay, loop analysis, right? And I'm going to explain this law. Okay, by drawing this circuit. Understand it, it's very important, guys. Okay, then you would be able to solve questions. So this is the circuit. Okay, and this is voltage E. Okay, and this is the one. This is this resistance is R. This resistance is R. Okay, understand carefully, guys, then you will be able to understand it. Okay, so this is one. Okay, okay, so this is the diagram, guys. Okay, this voltage is 2E. Okay, so now we can use loop analysis. Okay, so Kirchhoff's voltage law equation is this one. Okay, KVL equation. KVL equation is sigma V equal to 0. Okay, so this is the KVL equation, guys. We will use this. Okay, so now what we are going to do is this one. We'll consider this as a loop 1, this as a loop 2. Okay, and we are taking current direction like this. Okay, clockwise, and this direction we are taking like this. Okay, clockwise. This is clockwise. Okay, or anti-clockwise. Okay, clockwise. Okay, so now how we are going to use it, that's what I'm going to explain. So this will take plus minus plus minus. Okay, this is going to be minus to plus. If it will go minus to plus, then the sign of voltage is going to be plus. Okay, and similarly if we are coming here, right, if it is like we are coming top to bottom, right, and so first plus is coming, then minus, means this sign is going to be negative. Okay, so now we'll analyze this first loop. In first loop we'll use KVL. Okay, in first loop, we are using KVL. Okay, so this is going to be this. Sum of the voltage is 0, right? Let's suppose the current here is I. Okay, this is this is I1. Okay, this is I1 and this is I2, and this current is going to be I1 minus I2, right? Because this is the total current is I1, and this, and then I2 current goes here, so this the remaining current is I1 minus I2. Okay, well, so we'll check the current direction. Current direction is here like this, right, clockwise, right, this direction. It means at this point the voltage is going to be IR, right, and the current direction is from positive to negative, right. It means we will take it as a negative value. If current if direction is like negative to positive, then will take positive value, IR, V equal to IR. So I'm going to use the loop analysis, means the KVL here, okay, in first loop. So this is going to be, this is minus to plus, okay. We are taking the direction of current is minus to plus for this, for voltage. So this is going to be E minus IR. Minus IR means because the direction is same, plus to minus, right? So this is going to be minus IR, right? Minus to plus, the sign will be plus, and plus to minus, the sign is going to be minus, right? So E minus I1 R, E minus I1 R, and then this is going to be this one. This is I1 minus I2, right? And this is plus to minus, right? This is minus. Minus, this is going to be, this is R. This is R, okay? This is going to be R into, or we can write I1 minus I2, I1 minus I2. I will solve one question, then it will be more clearer to you. So I1 minus I2 into R. In this loop, right, this is E minus to plus, then plus to minus, direction towards direction. So IR minus I1 R, and this one I1 minus I2 into R, okay. This, in this loop, this is going to be equal to 0. This is in first loop, okay. In first loop we have used KVL. Similarly we'll use in second loop, okay. In second loop, in second loop, in second loop, this is going to be this one, right? This is the direction of current, right? Direction of current is this. So this is the resistance, then so this is going to be same direction, right? So this is going to be plus minus means minus. So minus I2R, this is going to be minus I2R, and then this one, this is plus minus, right? Plus to minus, the direction is for voltage. So it means this the 2E will be, the sign of 2E will be minus, right? So this is minus 2E, minus 2E, okay, and then minus this one, this is coming here, right? This one, this I2, this is coming here. So the, here you can see the direction is this, this direction is this, right? I1 minus I2. Now we are coming from here, right? So this current direction is going to understand this. This is very important for us. So because we we are coming like this, right? Clockwise. This. So this is minus I2R minus E2, and this is going to be minus I2 minus I1R, guys. Okay. So this is minus I2 minus I1R equal to 0. So this is the this this is how we use this KVL, guys. Okay, right? So for this, in this loop, you can say, you can see this E minus minus I1R, okay, minus I1 minus I2R, okay, in this direction. When we are coming, but in second loop, you can see this is minus I1R minus E minus 2E, because plus minus, right? Direction is from plus to minus. This is minus 2E, and this is minus, this is going to be I2 minus I1, okay, I2 minus I1. In this first loop it will be I1 minus I2, and in second loop it is going to be I2 minus I1, I2 minus I1 equal to 0. This is how we use we'll use the loop equation. We'll make a loop equation, okay. Well, so now I will solve one question to clear your all doubts, okay, which will clear your which is going to clear your all doubts, okay. So question is, I'll make a figure. So this is going to be This is the question. This is 2 ohm. This is 4 ohm. Okay. This is 6 volt. This is 4 ohm. This is 2 ohm. You can try to solve this question by KCL also, by on nodal analysis also. Okay. Okay. So this is 2 ohm. This is 4 ohm, and this is the voltage, right? This is the voltage, guys. This is 4 volt. Okay. Now we need to solve this by this KVL. Okay, by KVL, Kirchhoff's voltage law. Okay, that is KVL equation is sigma V equal to 0. This is V voltage, right? Sum of voltage equal to 0 in a loop. In a closed loop, sum of voltage is equal to 0. That is the Kirchhoff's voltage law, right? Okay. So now we'll take this as clockwise, and this is also we are going to take clockwise direction of current. Okay, this is plus minus, and this is plus minus. Okay, plus minus means sign will be negative. Okay, this is minus plus. Okay. Okay, so in loop 1, so this current is I1, guys. Okay, this is I2. So the reason current is not going to be divided here because there is no resistance. Okay, so now in loop 1 it is going to be in loop 1 it is going to be in loop 1. Understand it, okay, guys? In loop 1, this is loop 1 and this is loop 2. So in loop 1, so we'll use KVL. It is going to be, this is 2 volt, guys. Okay, this is 2 volt. So this is going to be 2 minus, this sign will be, and this is the current direction, means this is going to be minus 2 I1. Okay, minus 2 I1. This is plus, right? Plus 4 minus, this is plus minus, right? This is the direction of current, right? Plus to minus 4 I1 equal to 0. So from here this is going to be minus 6 I1 plus 6 equal to 0. That implies I1 equal to 1 ampere, right? 1 ampere. Okay, now we'll use KVL in second loop. Okay, using KVL in second loop. Okay, using KVL in second loop. So this is the second loop. Okay, again direction of current, this is plus minus, right? So this is this here voltage is going to be IR minus IR, right? 4I2, this is 4I2 minus 4I2. Okay, and here this is plus to minus means minus 6, and here you can see the direction is plus to minus, right? See, this is the current direction. Okay, so this is going to be minus 2 I2, and this is, here you can see plus to minus means minus 4 equal to 0, right? Minus 4 I2 minus 6 2I2 minus 4 equal to 0. So from here it is going to be minus 6 minus 6 I2 minus 10 equal to 0. So from here I2 is going to be minus 10 upon 6, that is minus 5 upon 3 ampere. right? So simply we have found the current and loop 2, right? Very simple question. I hope guys you have understood it. Okay, next question. Next question is this one. Question that is again I'll make a diagram for it. So this is okay. Okay, this is 2 ohm. This is 3 ohm. This is 5 volt. This is 20 volt. This is 10 volt. Okay, and this is uh, 3 ohm. 3 ohm. There is one more resistance here. Okay, and this is 3 ohm. Okay, so this is the one solved by loop analysis. Loop analysis, that is KVL. So this is, so we are going to take current direction like this. Okay, this is loop 1 and this is loop 2. Okay, so in loop 1 using KVL, so this is going to be, we'll take it, this is plus to minus, right? So plus minus, right? Plus to minus, so this is going to be minus 20 minus this is I1 guys. Okay, this is I1, this is I2. Okay, and this is going to be I1 minus I2, right? So in this loop this is going to be 2 minus 20 minus 2I1 minus 2I1 minus this is 4 ohm guys. Okay, 4 ohm. So this is going to be 4 into I1 minus I2, I1 minus I2. Okay, and this is again minus 3 I1 minus 3 I1. Okay, and this is this one. First I'll write minus to plus, right? So this is going to be minus 10 plus to minus, right? And then this is going to be minus 3 I1, right? This is equation 1. Now in loop 2 we'll use KVL, that is sum of voltage is equal to 0, right? So in loop 2 this is going to be, this is I2, right? And this is 3 ohm minus 3I2 minus 3I2 minus, because plus to minus means minus 5, and this is minus 3I2 minus 3I2 two times, right? Have you made any mistake? Minus 3I2. This is 5 ohm guys. Okay, this is 5 ohm. This is 5 ohm. This is going to be then 5, and this is 5I2, right? 5I2, and then minus to plus, so plus 10 minus, this is here, this current direction is this, right? And we are taking like this. Okay, this we are going like this in this direction. So this is going to be very important, 4 I2 minus I1 equal to 0. Here we have in this loop we have done I1 minus I2. I told you this is important step. So here it is going to be minus 4 I2 minus I1, because current direction is down and we are going up, right? So this is the equation 2. Now you can easily solve this these two equations. Okay, if you solve this, you will get equation in I1 I2. If you solve it, you will get equation in I1 I2. Then you can solve those two equations and get the value of I1 and I2. Okay, next question, guys. Last question. Last question is this is the question. Okay, this is again, I'll make a diagram first. So this is okay. This is 4 ohm. This is 10 volt. This is 6 ohm, and this is 20 volt. Okay, right. So now we need to solve this equation, this by KVL, guys. Okay, so again we'll take this is I1, this is I2, and this current is going to be I1 minus I2. Okay, this is 6 ohm, right? So in loop 1 we can easily use it, right? From here this is 10 minus 2 plus minus 4 I1 simple minus this 6 into I1 minus I2 equal to 0. Similarly, this we are going to solve it, right? This is going to be minus plus, right? This is the direction. This means this is 20 minus this is I2, right? 6 I2 minus this, you need to understand the current direction is this side and we are going up, right? So this is going to be 6 I1 minus I2 means it is going to be I2 minus I1 equal to 0. Okay, it's simple. Now you can solve it, you will get the answer, guys. So guys, so I hope you have understood the nodal analysis method of solving questions related to circuit, right? Electronic circuit. And also I have explained today the KVL, and also I solved questions related to KVL. So now you know two methods, that is KVL and nodal analysis using KCL, right? And by that you can easily solve questions related to electronic circuit. Okay guys, so before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and